All right, back again. We got a energy and momentum quiz here for dynamics. In this question, we are given a 1.4 kilogram spaceship that is launched straight upwards from 0 speed. The thrust is constant at 35.4 newtons until the rocket reaches a height of 26.8 meters, and there the thrust ends. So we're being asked to find the speed of the rocket when the thrust does end. So using the equations from our energy and momentum section, much like what was on the energy and momentum homework that I posted last night, we use the equation T1 plus U from position 1 to position 2 is equal to T2. We know that our coefficient of U from 1 to 2 is equal to the force times the distance. Now the force is the thrust minus the weight of the rocket. And we get the weight by doing a simple mass times gravity. And there, as we plug that in, we find that our U is equal to 580.6 or 581, but I chose to keep the other decimal points just for calculation purposes. And as we move on, we know as the velocity is 0 at the beginning, we know that T1 is equal to 0. And from there, we have our T2, which is where we try to find our second velocity at the end of the thrust, is equal to 1/2 times the mass of the rocket. Plugging in all these known values and manipulating the equation to find our V2, we find that our V2 is equal to 28.8 meters per second or 29 meters per second if rounding up.